What happens when you eat honey for 30 days? Let's start with improved digestive health. We know that we get enhancement of gut flora, and honey's role as a prebiotic is foundational to its health benefits, particularly regarding digestive health. Prebiotics are dietary fibers that feed the beneficial bacteria in the gut, known as probiotics. These beneficial bacteria play a critical role in maintaining gut health, synthesizing vitamins like vitamin K and some B vitamins, and enhancing the immune system. Raw honey, which is less processed than commercial honey, retains more of its natural prebiotics and antioxidants. It provides a food source for probiotics, particularly bifidobacter and lactobacilli, which are crucial for digesting dietary fiber, preventing the growth of harmful bacteria, and maintaining a healthy gut barrier. A balanced gut microbiome facilitated by the regular intake of prebiotic-rich foods like raw honey can lead to improved nutrient absorption, as these beneficial bacteria produce enzymes that break down nutrients for easier absorption in the body. Moreover, a healthy gut microbiome is linked to a reduced risk of chronic diseases such as insulin resistance, obesity, type 2 diabetes, and even heart disease. Honey is also anti-inflammatory, and these effects can be found in the digestive system. We know honey's anti-inflammatory properties are primarily attributed to its antioxidant components, including flavonoids and phenolic acids. These substances can neutralize free radicals and reduce oxidative stress, which is a common pathway for inflammation. In the context of the digestive system, inflammation can lead to various uncomfortable conditions, including gastritis, which is the inflammation of the stomach lining, and GERD, or gastroesophageal reflux disease, where stomach acid irritates the esophagus. You get a backwash of acid up into the esophagus. Honey's soothing effect on the digestive tract can help manage these conditions by coating the lining of the stomach and esophagus, providing a protective barrier against stomach acids and irritating foods. If you have persistent symptoms, please get them evaluated. Do not continue to take honey. I want to be really clear about that because you can sometimes mask more serious things that are going on. This protective effect not only helps to reduce current inflammation, but may also prevent future episodes of irritation and inflammation. As I stated earlier, if you have persistent symptoms, get those evaluated by your healthcare provider. Honey is also helpful in aiding in digestion and alleviation of digestive disorders. The enzymatic content of honey plays a pivotal role in digestion, particularly in the breakdown and assimilation of carbohydrates. Honey contains enzymes like diastase, which is amylase, invertase, and glucose oxidase, which help in the breakdown of starches and sugars. This enzymatic breakdown helps in pre-digesting these carbohydrates before they enter the lower digestive tract, making it easier for the body to absorb these nutrients and reducing the workload on the digestive system. This can be particularly beneficial in conditions like constipation, where honey's mild laxative effect due to its content of fructo-oligosaccharides can help stimulate bowel movements and alleviate symptoms. Additionally, the osmotic effect of honey can draw water into the colon, making stools softer and easier to pass. For individuals with bloating, honey's prebiotic effect can help balance gut flora, reducing the overproduction of gas by harmful bacteria, and thus helping to alleviate discomfort and bloating. In this study, the potential of honey as a prebiotic food to re-engineer the gut microbiome toward a healthy state, the review published in Frontiers in Nutrition in July of 2022 substantiates honey's prebiotic potential to enhance digestive health. It highlights honey's bioactive properties, including antibacterial and anti-inflammatory activities, and its content of non-digestible carbohydrates like oligosaccharides. These compounds promote beneficial changes in the gut microbiota, such as increasing lactobacillus and bifidobacter, while reducing infection-causing bacteria like Salmonella and E. coli. This evidence underlies honey's capacity to support healthy gut function, regulate microbial communities, and reduce infection and inflammation, showcasing its prebiotic efficacy. Honey has antimicrobial properties that are attributed to its hydrogen peroxide content, low pH, and the presence of methyl glyoxal, especially in Manuka honey. These compounds provide honey with the capability to inhibit the growth of harmful bacteria, fungi, and viruses. The low water activity in honey also dehydrates bacteria, further preventing their growth. This broad spectrum antimicrobial activity supports the immune function by reducing the body's bacterial load, potentially lowering the incidence of infections. Research has shown that honey can act against Staph aureus, Pseudomonas, and even certain antibiotic-resistant strains, making it a valuable adjunct in infection control and treatment. Honey is an antioxidant powerhouse. The antioxidant properties of honey are derived from its rich content of phenolic compounds, flavonoids, enzymes, and ascorbic acid, which work collectively to scavenge free radicals. Free radicals are unstable molecules that can cause oxidative stress, leading to cellular damage and a host of chronic diseases. By neutralizing these free radicals, the antioxidants in honey help protect cells from damage, thereby reducing the risk of inflammation and enhancing the body's disease-fighting capabilities. Studies have suggested that regular consumption of honey can improve antioxidant status in individuals, further bolstering immune health. Honey has also been found to modulate the immune system, enhancing both innate and adaptive immunity. It can stimulate the production and activity of various immune cells, including B and T cell lymphocytes, as well as phagocytes, which are crucial for a robust immune response. Honey also influences the release of cytokines, which are signaling proteins involved in the regulation of immune responses and inflammation. Some types of honey, such as Manuka, have been specifically studied for their ability to enhance immune function, showing potential in boosting the immune response against pathogens. This immunomodulatory effect, combined with its antimicrobial and antioxidant activities, makes honey a natural ally in supporting immune health. In this particular study looking at honey and health, a review of recent clinical research, the review published in Pharmacognosy Research highlights honey's multifaceted role in boosting immunity. It underscores honey's phenolic compounds for their antioxidant, antimicrobial, and anti-inflammatory, as well as immune modulatory effects. These compounds, notably flavonoids and polyphenols, have been shown to enhance immune response by stimulating the production and activity of immune cells such as lymphocytes, neutrophils, and eosinophils. This scientific evidence supports honey's potential in strengthening the immune system and suggests its therapeutic application in managing various diseases, highlighting honey's significance beyond its nutritional value. I'm interrupting this video because I would love for you to grab my intermittent fasting quick start guide. You can click the link below and grab it now. Interestingly enough, there is research to suggest that honey can be involved in the regulation of our sleep-wake cycle. Consuming honey before bedtime can have a positive impact on sleep quality due to its ability to help regulate the sleep-wake cycle. Honey triggers a small increase in insulin levels, which facilitates the tryptophan in honey to enter the brain more easily. Tryptophan is a precursor to the neurotransmitter serotonin that gets converted into melatonin, which is the hormone responsible, or one of many hormones responsible for sleep regulation. Melatonin not only helps in regulating sleep patterns, but also in enhancing the quality of sleep. It is thought that honey's steady supply of liver glycogen ensures that the brain has enough energy during the night, preventing or reducing the likelihood of sleep disruption. There are many things that go into sleep disruptions. I would suggest not going overboard with the quantity of honey. If you're going to try this before bed, maybe try a teaspoon to start. The natural sugars in honey lead to a controlled increase in insulin and allow tryptophan, an amino acid that promotes sleep, to enter the brain more easily, where it is converted into serotonin and eventually melatonin, which is a sleep-promoting hormone. This biochemical process can have a calming effect on the brain, reducing stress and anxiety levels, which are common culprits behind sleep disturbances. The antioxidants in honey also may play a role in stress reduction, further contributing to a more restful night's sleep by lowering oxidative stress within the body. Let me be clear, for middle-aged women, there's a lot of things that can impact our sleep quality. Again, go small and low with honey if you decide to try it. Honey consumption before sleep may help provide a stable source of glucose necessary for the brain's overnight functions, preventing the body from activating stress responses that can disrupt sleep. When our liver glycogen stores are adequate, the body does not need to release stress hormones like cortisol or adrenaline, which can interfere with sleep. This can help ensure a more restful and uninterrupted sleep cycle, as the body does not enter a state of alertness that could lead to awakenings. By maintaining a balance in energy levels through the night, honey helps in promoting deeper and more restorative sleep stages. In this study, tryptophan and biogenic amines in the differentiation and quality of honey, the study published in the International Journal of Tryptophan Research highlights honey's significant potential to support sleep through its content of tryptophan and its metabolites, which are precursors to serotonin, melatonin, and even dopamine. These neurotransmitters play crucial roles in sleep regulation and mood balance. The research emphasizes the variability of these compounds in honey, influenced by geographical and botanical factors, underlying honey's nutritional value in enhancing sleep quality and overall well-being. There's also some research to suggest that honey can be helpful in balancing blood sugar levels. Honey's lower glycemic index means it doesn't spike blood glucose levels as sharply as table sugar. This property makes it a better choice for maintaining more stable energy levels throughout the day. The unique combination of natural sugars in honey, including fructose and glucose, contributes to its slower absorption rate into the bloodstream. This slower absorption rate can help in managing energy levels more effectively, preventing the rapid highs and lows often experienced with the consumption of higher GI foods. Lower glycemic index of honey can be beneficial for overall health by avoiding the stress on the body's insulin response system that is typically aggravated by high glycemic index foods. The antioxidants in honey, such as flavonoids and phenolic acids, may play a role in improving insulin sensitivity. Improved insulin sensitivity helps the body's cell better respond to insulin, making it easier to maintain balanced blood sugar levels. This effect can contribute to a reduced risk of developing insulin resistance, type 2 diabetes, metabolic syndrome, and may aid in managing the condition for those who have it. Again, if you are insulin resistant or diabetic, less carbohydrates are better. Research suggests that long-term consumption of honey may have beneficial effects on metabolic health, including improved insulin sensitivity and reduced inflammation. I'm going to keep saying this over and over again. If you are insulin resistant or diabetic, you need to lower your carbohydrate threshold. So don't overdo it if you decide to consume honey. Additionally, consuming honey may offer protective effects against metabolic syndrome, a cluster of conditions that increase the risk of cardiovascular disease and stroke. Honey's specific anti-inflammatory and antioxidant properties can help mitigate some of the risk factors associated with metabolic syndrome, such as insulin resistance, high blood pressure, and abnormal lipid levels. Studies indicate that honey can positively affect these parameters, contributing to overall metabolic health. However, it's crucial to consume honey as part of a balanced diet and not rely on it as a solo treatment for metabolic conditions. Again and again and again, I will continue to reiterate that. Protein-centric diets, right types of fats, low carbohydrates if you are diabetic or insulin resistant. In this study, looking at a review on the protective effects of honey against metabolic syndrome, this 2018 review published in Nutrients demonstrates honey's protective effects against metabolic syndrome, highlighting its low glycemic index, which can aid in blood sugar regulation, potentially weight management, and improved lipid metabolism. The study suggests that honey enhances insulin sensitivity, reducing the pancreas's overstimulation risk and mitigating oxidative stress, which is a key metabolic syndrome mechanism. Additionally, honey's benefits extend to vascular protection, showcasing its broad potential in metabolic syndrome management as both a preventative and adjunctive therapeutic agent. Stay tuned for my next video, how to stop sugar cravings.